If you remember from section 4.6, and if you don't remember, you can go back and look. In 4.6, we talk about a type of sequence called arithmetic sequences. Okay, today in section 6, we're going to be talking about a different type of sequence called geometric sequences. Okay, so what a geometric sequence is, and it is a vocab term, it's a series of numbers where the ratio between each pair of consecutive numbers is the same. Now, in arithmetic sequence, this word was different. It wasn't ratio, it was difference. Okay, so in an arithmetic sequence, we were like adding 3 every time, or subtracting 5 every time, or adding a half, or whatever. In geometric sequences, it's a little different. Let me erase this here. In geometric sequences, we're going to be multiplying every time, or dividing every time. And if we're dividing, we can actually rewrite that as multiplying. So really, it's multiplying every time to get to the next term. The ratio between each pair of numbers in a geometric sequence, now we're to this vocab term, it's called the common ratio. Remember, in an arithmetic sequence, we had a common difference. Now we have a common ratio. Let me give you an example of a geometric sequence. Could be 1, 5, 25, and 125, and then it would go on forever. But I'm just going to write those first 4 terms. Okay? What I hope you notice is that to go from 1 to 5, that's times 5. From 5 to 25, also times 5. And I don't know what that was supposed to be. That's supposed to be a 5. And from 25 to 125 is times 5. Okay, so this is an example of a geometric sequence. And these numbers down here make up your common ratio. The numbers that I wrote here in red, not ration, ratio, erase that. Those numbers, the times 5, times 5, times 5, that's showing that there is a common ratio and that it is a geometric sequence. Okay, so there's one example. We'll work with plenty of them throughout this video. All right, so let's just start by trying to recognize whether something is arithmetic, geometric, or neither. Okay, so for number 1, 120, 60, 30, and 15. Well, I know that in order to go from 120 to 60, that would be like dividing by 2. And instead of writing dividing by 2, the same thing you could do, or you could rewrite dividing by 2 as multiplying by 1/2, multiplying by 1/2. To go from 60 to 30, again, that's dividing it by 2, cutting it in half. So times 1/2. And to go from 30 to 15, again, times 1/2. The ratio between each term is the same. Okay, so this is in fact a geometric sequence. The common ratio, these 3 numbers, are the same. And we're not adding or subtracting, so it's not going to be arithmetic. We are multiplying or dividing, so that makes it geometric. And since these 3 are the same, it is a geometric sequence. Okay, number 2, 2, 6, 11, and 17. Well, let's check and see if it's geometric. If it's geometric, how to go from one term to the next will be the same, and it'll be times something. So this number would be the same, and then if I do another arrow, that one would be the same, and then that one would be the same as well. Okay, so to go from 2 to 6, that would be times 3. 6 to 11. Well, I'm pretty sure 6 times 3 is not 11. So this one's going to be like times, it's a little more than 1.5. We'll call it 1.8. So right now we can stop because these 2 numbers are not the same. Okay, so we know that it's not geometric. Not geometric. Okay, so now let's go check arithmetic. So I'll check my geometrics in yellow, I'll do my arithmetics in red, and then I'll do, if it's neither, I'll write that in blue. Okay, so let's check the arithmetic. So to go from 2 to 6, that would be up 4, plus 4. To go from 6 to 11, well, that's not plus 4, that's actually plus 5. If this was going to be an arithmetic sequence, these numbers still have to be the same. Okay, so since they're not the same, it's not arithmetic either. Not arithmetic. So if it's not arithmetic and not geometric, then the answer here is neither. Okay? The answer for number 2, neither. It's not geometric, not arithmetic, so it's neither. Okay, let's try number 3. Let's check our geometric first. 5, 1, negative 3, negative 7. Well, to go from 5 to 1, that would be like dividing by 5. Or instead of dividing by 5, we could say times 1/5. Okay, and then from 1 to negative 3, I'm pretty sure 1 times 1/5, well, that's 1/5. That's not negative 3. Okay, so pretty sure this is not geometric. Not geometric. Because if it was geometric, 1 times 1/5 would be negative 3, and that's clearly not the case. Okay, so let's check arithmetic. So from 5 to 1, that would be subtracting 4. 1 to negative 3, subtracting 4. We have some promise here. And from 3 to negative 7, hey, that's subtracting 4 again. So this sequence, number 3, this one is arithmetic. We have a common ratio, or not a common ratio, a common difference between each term in the sequence. Okay, so arithmetic for number 1 or number 3, neither for number 2, and geometric for number 1. So we've had an example of each. Let's see what we can do with number 4. So let's try, let's figure out what number 4 is going to be. Okay, so to go from 1024 to 128. I have no idea what that is in my head. So what I'm going to do, I'm going to take 1024 and divide it by 128. This one, I don't know this in my head, so I'm going to use my calculator, type in 1024, divide by 128, and what I'm going to get is 8. Okay, so this would be like dividing by 8, or you could say times 1/8. Okay, to go from 128 to 16, if this isn't going to be a geometric sequence, then 128 divided by 16 should be 8. And when I type this in my calculator, I do in fact get 8. So again, dividing by 8 or times 1/8. I would really like you to get in the habit of using 1/8, because I'll explain why here in a little bit when we get to writing equations of geometric sequences. 1/8 is going to be much more valuable to us than dividing by 8. And then lastly, 16, that one I can actually do in my head. 16 divided by 2 is 8, so dividing by 8 or times 1/8. So the common, or the ratio in between each of the terms is the same, so that in fact makes this a geometric sequence. Metric, it needs to be over there. So number 4 is geometric, number 3 was arithmetic, 2 was neither, and then 1 was geometric as well. All right, write the next 3 terms of the sequence. So remember in section 6, I'd give you 4 terms. You'd have to tell me the next 3. We're going to do the exact same thing here. Number 1, we're going to have 3, 6, 12, 24, and then so on. My question, or what I'm hoping that you see right away, is the common ratio. We're talking geometric sequences, so it's got to be times something. How do we go from 3 to 6? That would be times 2. To go from 6 to 12, again, times 2. 12 to 24, also times 2. So to find the next 3 terms of the sequence, we just need to continue the pattern. Okay, so we'll have 24 times 2, that gives us 48. We'll have 48 then times 2, that's 96. And then lastly, 96 times 2 is equal to 192. So your next 3 terms of your sequence are right here, 48, 96, and 192. Let's try another one here. Number 2, 64, negative 16, 4, positive 4, and negative 1. And we'll continue the sequence. Okay. How do we go from 64, positive 64, to negative 16? Well, if we're going from positive to negative, that means we need to multiply by a negative. And if we're getting smaller, it's like we're dividing by something. 64 divided by negative 16. We could do 64 divided by negative 16. What that will give us in the end is negative 4. So to go from 64 to negative 16, that would be like dividing by negative 4. But again, if we want to write this as multiplication, we could turn dividing by negative 4 into multiplying by its reciprocal, negative 1/4. Okay, so negative times negative 1/4 to go from 64 to negative 16. And then to go from negative 16 to positive 4, since we're switching signs, we need to multiply by a negative. 16 divided by 4 is 4, so then it makes sense to say negative 1/4 here as well. And then from 4 to negative 1, again, multiply by a negative, And dividing by 4, same thing as multiplying by negative 1/4. Okay, so let's continue the pattern. So we've got our common ratio, negative 1/4. Let's get our next three terms sorted out. Okay, so our last term that we were given was negative 1. If we take that times our common ratio, negative 1/4, this one shouldn't be too difficult. 1 times anything is just going to be this anything. Okay, so our next term will be 1/4, positive 1/4, because we had negative times negative. Negative times negative is a positive. Okay, and we'll just continue the pattern. Whoops, go back to the pen here. Positive 1/4 times our common ratio, negative 1/4. We're multiplying fractions, multiply straight across. Positive 1 times negative 1 is negative 1. 4 times 4 is 16. And then do it one more time. Negative 1/16 times our common ratio, negative 1/4. Multiply straight across. Negative 1 times negative 1 is a positive 1. 16 times 4. If you don't know that off the top of your head, you can punch it in the calculator. You'll get 64. So your next three terms of number 2 would be 1/4, negative 1/16, and positive 1/64. All right, let's try graphing one. Let's see what it looks like. What does this shape look like? Okay, so graph the sequence. What do you notice? So number 1, and we're actually just going to do one example with, or one problem with this example. What we're really going to notice, this part, what do you notice? That answer is going to be the same for every problem. So the graphing hopefully doesn't make, or doesn't confuse you too much, because every problem works pretty much the same way. All right, so your sequence: 32, 16, 8, 4, 2, and so on. Okay, graph the sequence. What do you notice? Let's start by graphing it. Before we graph it, what I'm going to do, I'm going to make a table. Okay, so our position in the sequence will be our x value, and then the actual term, the value of that position, Rm, that's going to be our y value. Okay, so I'm going to make 5 spaces, term 1, or position 1, 2, 3, 4, 5. Now the y values for these x's come from your actual sequence. So the first position in your sequence is 32. So the y value for position 1 is going to be 32. And then we'll just go down the line. 16, 8, 4, and 2. Okay, that's a 2. All right, so let me bring in some graph paper here. Let's graph this. Now I'm going to set my y-axis by 8s. So this is 32. And then 24, so that needs to be in black. 24. And then 16, 8, 4, and 0's down here. 0, and 1, 2, 3, 4, 5, and we'll label those 1, 2, 3, 4, 5. Okay, so let's put our ordered pairs on the graph. So we got 132, which would be right there, 1, 32. 216 is there. 3, 8 is there. 4, 4 is there. And 5, 2 is going to be right in there. So clearly, the graph is not a line, does not form a line. What it does, though, if we were to kind of sketch a picture here, what that should kind of look like is an exponential curve. And that's the whole point, is the graph, and we'll write this off to the side, the graph, or the points on the graph, makes an exponential curve. Okay, the graph makes an exponential curve. Every time you have a geometric sequence, this is going to be what your picture looks like. Now, if this was, this could also go something like this. Okay, the one that I drew here in green. Okay, it could be getting bigger every time. Obviously, in this example, we're getting smaller. But you're never going to have something that looks like this or like this. You're never going to have a straight line. Okay, you're always going to have an exponential curve with a geometric sequence, which kind of leads me to the next part, writing equations for geometric sequences. If our graph is an exponential curve, then our equation is actually going to be an exponential equation as well. Okay, so for writing equations for geometric sequences, here's your formula. A sub n, so that's the nth term, is equal to a sub 1 times r to the n minus 1 power. Now I'm going to explain or elaborate which or what variables stand for what. Okay, so a sub n is your nth term. Okay, so if I want the 10th term, that becomes a sub 10, or if I want the 15th term, that's a sub 15. It's just a placeholder. A sub 1, just like in geometric or arithmetic sequences, that's your first term. Okay, a sub 1 is your first term. Your r value, that is your common ratio. Common ratio. And then n just stands for whatever number we're working with. The two values that we need to know to be able to write an equation is the first term, or are the first term, and the common ratio. Those are the two that we need to have. So I'll put that in green. Need to have or need to know. Okay, we need to know the two that we wrote in, that I underlined in green. The first term and the common ratio. If we have those two, then we can write equations for geometric sequences. So let's try a couple here. Write an exponential equation for the nth term. Then find the 10th term. Okay, so number 1, our sequence is going to be 1, negative 5, positive 25, and then negative 125. So we have a couple tasks. We need to write an exponential equation, and then we need to find the 10th term. Remember, like we said, the two things we need to know: first term, common ratio. So, first term, common ratio. First term, whatever number is listed here first, that's your first term. So, number 1, or is the value of 1. Common ratio. How do I go from 1 to negative 5? Well, that would be times negative 5. And then if I do negative 5 times negative 5, that gets me to positive 25. And if I do positive 25 times negative 5, that gets me to negative 125. So my common ratio here is negative 5. Okay? So once I've got my first term and my common ratio, I can go ahead and write my equation. A sub n is equal to my first term, 1, because I'm just using this formula here. First term times common ratio, putting it in parentheses, to the n minus 1 power. Okay, there's the first part. Write an exponential equation for the nth term. Now we'll go over to the second part, find the 10th term. The only thing that changes now is we're filling in n. Okay, so a sub 10, meaning the 10th term, is 1 times negative 5 to the 10 minus 1 power. Now, negative 5 to the 10 minus 1, we can clean that up. So a sub 10 is equal to 1 times negative 5 to the 9th power. Negative 5 to the 9th power, you can use your calculator for that. Just be very careful that you're using parentheses, because we're taking a negative number. The base is negative base to an exponent. So this becomes 1 times negative 5 to the 9th power is negative 1,953,125. I did that in my calculator earlier. And then for this last step, 1 times anything is just going to be that anything. So our 10th term is going to be negative, I think this ends up being negative 1,953,125. Okay, so write an exponential equation for the nth term. We did that. They're in blue. Find the 10th term. If we were to continue this sequence for the next 6 terms, you can see that it's going to get very large very fast, and we're in the negative nearly 2 millions. Okay, let's try another one here. Number 2. Let's go with 13, 26, 52, and 104. All right. Again, the two things we need to know. I'm doing this in green to start. I need to know the first term, and I need to know the common ratio. First term, well, it's your first term listed. That's 13. Question for the common ratio. How do I go from 13 to 26? That would be times 2. 26 to 52, also times 2. 52 to 104, again, times 2. So our common ratio is positive 2. Okay, so we have our first term, we have our ratio. Let's write our equation. A sub n is equal to our first term, 13, times our ratio, which is 2, to the n minus 1 power. That is your answer for the first part. Write an equation for the nth term. We did that. Okay, now let's find our 10th term. Okay, so a sub 10 is equal to 13 times 2 to the 10 minus 1 power. We can do 10 minus 1. 13 times 2, 10 minus 1 is 9. 2 to the 9th power. Again, type it in your calculator if you don't know it. It should be on your half sheet. That would be 512. Whoops, that was supposed to be a scroll. 13 times 512. Again, type that in your calculator. I'm not expecting you to know that off the top of your head. 6,656. So the 10th term of this sequence, 13, 26, 52, 104, and technically that goes on forever, would be 6,656.